Okay, ready, focused? Okay, so what stoichiometry is it's a fancy way of saying, you know those precipitation reactions we did yesterday?
Yes.
If we could calculate the mass that we would predict would be our precipitate, we'd have to do stoichiometry to do that. Okay? So you need a balanced chemical reaction. You're going to do the mole ratios of them, and then you're going to use all the formulas that we have learned thus far. And that's this whole unit. Okay? They start with a small bit, today being the mole ratio bit, and then we work our way through our formulas that we already have experienced, and then we mix them all up. So then you need to figure out which formula to use, and that's the end of the unit. So it kind of is the same thing repeated over and over and over again. So if you get it the first time, you'll be great. Or not necessarily the first time, but anyway. If you get it early on in the unit, you find this unit rolls quite quickly. If you bury your head in the sand and hope it'll go away, it doesn't go away. It's the same thing again tomorrow. Yes, Zach?
How many more units do we have?
This one and then one more after this. Okay.
Are they longer units or?
No.
Short?
They better finish by June.
Well, it's
May. Well, nearly.
so we got 2 months.
Yeah, we got 2 months, 2 units, plenty of time. And a review. Review for our final.
Yeah.
Okay, so the first thing we're going to do is we're going to have a look, and we're going to concentrate today on what the mole ratio is, and a bit about Science 10 that we need to master before we conquer this unit. So, and you're annotating along with your package as we go through, as opposed to staring blankly at the board and hoping it'll just sort of leap into your memory. You've got to actively participate. Okay, so we're going to write a balanced chemical equation first. I can guarantee there's still people in this room that are going to find that bit difficult. Converting the sentence into a Science 10 reaction that's balanced. Okay? So remember how we've already practiced that from our net ionic equations, right? So we're doing it again, more of it. So that's the first thing. The second thing is we're going to write the information given under the chemical it refers to. So we're going to write the info underneath the chemical that we put in our chemical equation. Then number 3, we're going to look at the mole ratio, which, by the way, are those big balanced numbers that we've been using. Then number 4, well, now you're not really listening to me by this point because you were kind of holding on to, now you're like, oh, I've lost you. It doesn't matter. So when we get to an example, you'll see we're going to put in the values that we were given in the question, and then we're going to answer it. Okay? So this is what I mean by those steps. And as we go through the example, you'll be like, ah, okay? But when we come back, if you are doing an example on your own, you might want to come back to these steps. Right, so question. How many moles of oxygen gas are needed to completely react with 3.50 moles of hydrogen gas to produce water vapor? How many of you from that paragraph can create that? Yes, just Connor?
Oh.
I would hope everybody, but I would expect 80% of you. So oxygen gas reacts with hydrogen to produce water. Okay, so blah, 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 blah. Then you balance it, big 2, and you're done. That's Science 10. Here comes the Chem 20 bit. The information for the hydrogen that it's been given to me is N equals 3.50 moles. Excuse me. Remember I've been telling you to make a little list for the math questions? This is our list. It's just underneath what it belongs to. And then over here, I have N equals question mark. Now right now you're like, why do I need to do that? That's an easy step. Because eventually, you'll have like 5 things. 5 numbers to sort out. And so these lists underneath that column for hydrogen and a list underneath the oxygen, that really helps you sort out all that reading comprehension in it. Okay? So right now it's kind of obvious, there's only 2 things. but it's good to get in this pattern because it'll help you. So, the balanced, big balanced numbers. It's important that you understand what those balanced numbers are. This means I need 2 hydrogens. So here's an H2, here's an H2. And when you guys made these things for me, it's like you went to Michael's or wherever you went to buy these things, to buy the styrofoam balls and sticks, right? You went there and you got a package that looked like that. And you went and you got another package down the aisle that looked like that. That's an O2, and that's 2 H2s. You okay with that? H2, H2, O2. And I can rip open those packages, and I can put them all together, and how many waters can I make? Here's one O, here's another O. Here's 1 hydrogen and 2 hydrogens, 3 hydrogens, 4 hydrogens. So that's ripped all up. And how many waters can I make? 2. Can you see that? Stick those together, I've made 2 waters. Those big numbers represent 2 packages and 1 package come together and make 2 molecules. So, similarly, if you went to Michael's and you didn't buy 2 packages, but rather you bought 4 packages. So 1, 2, 3, 4. How many packages of oxygen would I need then? 2. And how many waters could I make then? 4. Did you get it?
Yeah.
Well, what if I go to Michael's and instead of buying 4 packages, I buy 3.5 packages? I need 1.75. So for 3.5, I'll need 1.75. And how many waters will I make?
3.5.
3.5. So for those of you that love ratios, you're going, yeah, I totally understand that. Right? Easy. For those of you that don't love ratios, I don't love ratios. Ratios aren't easy for me to go 3.5 and 1.75. That doesn't come naturally to me. I have to kind of stop and think about it. So the reason it works that way are these moles cancellation bit. So, where are we going here? 3.50 moles equal to, 2 moles of hydrogen to 1 mole of O2. So 3.5 moles to question mark. That's the ratio, right? I need to see this in your work. I need to see the fact that you have pulled out the big numbers properly. Okay? 3.50 moles of H2 divided by 2 from the big balanced number. It's getting quite messy now, isn't it, up here? 2 from the big balanced number, 2 times 1 mole of O2, 1 from here. Can you see how the moles of hydrogen cancel out?
Yeah.
One on the top, one on the bottom. And I'm left with moles of oxygen. And so my answer can be in moles of oxygen, and my numbers are just, well, 3.50 times 1 divided by 2. You see how that worked? That's a really good thing, because that's why it works. If you can see that, that's about on the top of the pyramid of the Bloom's taxonomy bit. Because it means you understand not just how ratios go times 2 divided by 2, I can multiply by 2, no problem. But actually, you get why it works. The units, if I times it by 1 and divide by 2, the units of the moles of hydrogen cancel out, and I'm left with moles of oxygen. Okay, then lastly I've said, for students who don't like the ratio and don't like the units canceling out, the little short, cheat way of memorizing, I don't get it. Am I supposed to multiply by 2, divide by 2? I get the 2-to-1 ratio, but I don't know what to do with it. You're the type of student that needs to memorize this. Multiply where you're going, which is cut off, so you might want to write it on yours. And divide where you've been. Multiply where you're going and divide where you've been. So this is what that means, for those of you that like to know it this way. Where am I going? I'm trying to find out information about the oxygen. So I'm going to the oxygen. So multiply where you're going. Where have I been? Well, this information. I've been at the 2 in front of the H2, so I'm dividing it by 2. Multiply where you're going, divide by where you're being. Okay? So whichever of the 3 methods help you go from 2 to 1 is 3.5 to what? Use that one. Use whatever works for you. Okay? So, example 2, where you have to fill in the blanks here. How many moles of ammonia gas can be produced by reacting 6 moles of hydrogen gas with sufficient nitrogen gas? Meaning enough nitrogen gas. So, could you have, I'm not sure why you're talking.
Sorry.
Could you have come up with a balanced chemical equation on your own?
Yes.
Yeah, so step 1 is to do that. What was step 2 again?
Step 2 was put the info.
Put the information underneath. So what information goes with the hydrogen?
6 moles.
So N equals 6.00 moles. Why have I put the 0.00 there? So I remember my significant digits. What information goes under the ammonia? N equals question mark. So Mrs. Reese-Brown really wants to see that you understand to pull the big numbers out of the balancing. So step 3 is about that. How many moles of hydrogen make how many moles of ammonia, according to the balanced reaction? 3 moles make 2 moles. Okay. So 3 cups of flour make 2 cakes. 3 moles make 2 moles. So 6 moles make, if 3 makes 2, then 6 must make 4, because this is times 2. So this would be times 2, so that's 4, for those of you that love ratios. What about the unit bit? 6.0 moles of H2 times how many moles of ammonia? 2. How many moles of hydrogen? 3. So the moles of hydrogen cancel out. I'm left with my answer of moles of nitrogen, which is what I'm trying to find out. Everybody get the unit canceling out bit. And for those of you that want to do times where you're going and divide where you've come from, whatever I said earlier, times where you're going, I'm going to the ammonia. The ammonia is 2, that's where my question mark is, so I've times it by 2. Divide where you've been. I've been at the hydrogen, there's my information, so I'm dividing it by the 3 from the hydrogen.
Sure.
Okay? That makes sense? Any questions? Max is sorting it out. Any questions? And the answer is 4 as it is down there. Okay, so practicing this, you're going to use your snap booklet, which takes you through the steps really nicely. So the snap booklet, page 186 to 189, just do the odds. If you need more practice, you can do the evens. And then when you're done that snap booklet, I want you to go and do this page 3 in your book. Okay? There's 2 things that I need to do, and I'll write these on the board for you after the projector goes out, but I'm just putting this on there for the sake of anybody out there. Ferrous nitride is Fe3+. Ferric, no, pardon me, ferrous is Fe2+. Ferric is Fe3+. And cupric is Cu2+. Okay? So I'll put them over there. I'll rewrite these old-fashioned names. I'll rewrite them into the names you're used to.
So that's
So that's copper 2 fluoride, iron 3 nitride, and iron 2 oxide. Yes.
I left my snap booklet at home, so do you have like an extra one?
Does Nick?
Yeah.
So you guys can look off of each other's and you can write yours on a blank sheet of paper since you'll be working together anyway.
Okay.
Okay. If you need another one, let me know, but.